All right, everybody, we are on our last day of negative exponents. So we're just going to keep on practicing and make sure we can try and see all of the different types of problems that there are out there with negative exponents. So let's jump right in. So if you take a look at number 1, we are going to start by dividing. So if I divide, I'm going to get negative 3. Remember, we're subtracting our exponents, so 3 minus negative 7 gives me a to the 10th. And then b squared divided by b squared is b to the 0, which is really just 1, and so we don't write it. So there's my final answer. Number 2, not much going on here. My only real issue is that I have a negative 3 for my exponent on a, and so I just need to get rid of that by rewriting this. So 6b to the 7th, that's going to stay in the numerator. A is going to go to the denominator and become positive. And that's it. Number 3, we have an entire monomial to a negative exponent. So when you see something like this, you're going to want to start by rewriting 1 over negative 12, a to the 3rd, b to the 4th, but now it's to the positive 2nd. And then we can go ahead and evaluate that. So 12 squared is 144, and then I'm going to get a to the 6th, b to the 8th. Okay. Number 4, I would definitely start by evaluating your powers here. So the first monomial is to the negative 3rd, so we're going to rewrite that to start. 3x to the 3rd, but now to the positive 3rd, times, and we can go ahead and square that monomial to get 16x to the 10th. And I'm going to put it over 1 because eventually I'm going to be dividing here. So right now let's go ahead and multiply the top. Gives me 16x to the 10th. And on the bottom, I'm going to go ahead and evaluate that to the 3rd power. So 3 to the 3rd power is 27. And then we multiply our exponents, so x to the 9th. Okay, and then we go ahead and we divide. So 16 divided by 27, I can't divide that and I can't reduce it. So I'm actually just going to leave it, 16 over 27. And then x to the 10th divided by x to the 9th is x to the 1st. So I'm just going to put that on the top with the 16 since it's a positive exponent. Number 5, looks like we need to take care of some powers first. So let's go ahead and square that first monomial. That's going to give us 64, x to the 4th, y to the 6th. And I can go ahead and square the second monomial to get 49, x squared, y squared. And then it looks like our last step is going to be to multiply. 64 times 49. Oh boy, I'm grabbing a calculator for this one. 64 times 49, 3,136. And then we're going to have x to the 6th power and y to the 8th. Okay, number 6. Let's go ahead and raise this whole monomial to the 3rd power. Again, the reason I'm doing that is because that negative exponent is not outside. If it were outside, I would have started by doing 1 over the entire fraction. Okay, but I don't have to worry about that just yet. So 1/5 to the 3rd power is 1/5 times 1/5 times 1/5, which is 1 over 125. And then I'm going to have x to the negative 9 because I multiply my exponents. So really my last step here is to put that x to the negative 9 to the denominator so that it becomes positive. So my final answer is 1 over 125 x to the 9th. Okay, number 17, it looks like we're going to need to put the entire thing under 1 because our outside exponent is negative. So this is negative 16 x to the negative 3rd y to the positive 1st. So just a reminder, when you put that monomial to the denominator, nothing in the monomial changes except for that outside exponent. So that's why I left that -3 there. Okay, think of the parentheses almost like a bubble. Nothing in the bubble changes, only the exponent on the outside. So now I have an issue because, well, first of all, that whole thing to the first power it doesn't change anything, right? So here's where I'm at right now. So the problem is that I still have a negative exponent in my answer. So remember we talked about how if we change its position, it changes its sign. So if I take that x to the -3rd and I put it to the top, it's now going to be x to the +3rd. So I'm going to do exactly that. Everything else I'm going to leave where it is because it's good to go. I already had positive exponents, and that's my final answer. All right, number 8. What is going on here? Let's see. So what I would do first is I would rewrite that first monomial to get rid of my negative exponent. So I'm actually going to write this as 12a over b to the 3rd. And then this other monomial I have here, there's nothing for me to divide, so I'm actually just going to leave it 2a over 3b to the 3rd. Now, you might be thinking, what do I do from here? So this is a little bit advanced, this problem. This is something that we might see more of next year, but I don't think it hurts to look at it now. So in order to subtract these two things, I need to have common denominators. And so the question is, how do I make it so that that first fraction has a denominator of 3b to the 3rd, right? Like that's what I need it to be so that I can actually subtract. Well, the way to do that is to multiply. And so what we're going to do, just like we would do in a normal situation where we had to get a common denominator, is I would multiply the top and the bottom by 3. And so when I do that, I'm going to get 36a over 3b to the 3rd. And now I can subtract the other fraction from it because the denominators are the same. So if you look at the numerators, 36a minus 2a is 34a. And remember, when we subtract fractions, we keep the denominator the same. So my answer looks like that. It's a little tricky, I know. Don't worry too much about seeing problems like that this year. All right, number 9, let's go ahead and multiply the numerators to start. So 5 times -7 is -35. X to the -3rd and x to the -2, if I multiply those, I'm adding my exponents, so x to the -5. And then there's a y to the -4th that we're going to have to just stick on there, divided by -5x. Okay, let's go ahead and divide. So I'm going to get +7, and then I'm going to write this over here for you, -5 minus 1. Remember, there's a 1 here. So that gives me x to the -6. And then y to the -4th gets brought along. Last step is to rewrite this without negative exponents. So my 7 stays in the numerator. And I'm going to make this into x to the 6th and y to the 4th. And we're good to go. Okay, number 10. I'm looking at the numerator and I'm seeing that I have a monomial squared here. So let's go ahead and take care of that. So -9 squared is +81. And then I'm going to get a to the -12, b to the -6, and c to the 10th. And then my denominator has nothing going on, so I'm just going to rewrite that. And now I'm ready to divide. So 81 divided by 81 is 1. You don't even need to write it. For my a's, remember we're subtracting our exponents. So -12 minus 11, that's going to give me a to the -23rd. And then I have for my b's, -6 minus -7, which is really b to the 1st, or just b. And then c to the 10th minus, or divided by, I should say, c to the 12th is 10 minus 12, which is c to the negative 2. So what I'm going to do now is I'm going to rewrite so that I have no negative exponents in my answer. So in the numerator, I just have a b, and in the denominator, I'm going to have a to the positive 23rd and c to the positive 2nd. Okay, for 11, let's go ahead and start by, actually, I have an idea for this one. So we haven't seen one like this yet, but I'm going to tell you right now that instead of rewriting both the numerator and the denominator as fractions to get rid of those negative exponents, why don't we go ahead and take the denominator and put it in the numerator, and take the numerator and put it in the denominator, because what that will do is it will change the sign of my outside exponents. Remember when I showed you guys how you could take 1 over x to the negative 6 and it would just be x to the 6 over 1? So I'm basically like changing where it goes. I can do that with this, and that's going to make our life a whole lot easier. So I'm going to start by doing exactly what I just said. I'm going to make this negative 36 a to the negative 4th b, but now it's to the positive 1st because I changed its position. And then the numerator now becomes the denominator and goes to b to the 3rd power. Okay, so that's a nice little trick you can use. Just makes it a little bit easier. So now I'm going to go ahead and evaluate those based on their powers. So the top isn't going to change because it's to the 1st power. So I'm just going to rewrite that. The bottom, negative 6 to the 3rd power, negative 6 times negative 6 is positive 36, and positive 36 times negative 6 is negative 216. And then I would have an a to the 3rd and a b to the negative 6th. Okay, so now I'm ready to divide. Well, negative 36 divided by negative 216, I can just reduce that. That actually reduces to positive 1/6. Okay, and then I'm going to divide a to the negative 4th and a to the 3rd. So remember, I'm subtracting. Negative 4 minus 3 would give me a to the negative 7. And then I have a b to the 1st divided by b to the negative 6. So 1 minus negative 6 is positive 7, so b to the 7th. So my last step is going to be to rewrite this to get rid of our negative exponent on the a. Now, right now, it's really at the top, right, because these are both over 1. So what I need to do is I need to keep the b to the 7th on the top, and I need to put the a to the 7th to the bottom with the 6. So that would be my final answer. Okay. What's going on here? I would say, why don't we square that first monomial, okay, and then we'll multiply. So 1/4 squared is 1/16, and then I'm going to get x to the 6th, y to the 4th. And I need to take that and multiply it by negative 6x to the 3rd. All right, so 1/16 times negative 6, I'm going to do that over here for you. This would be negative 6/16, which I want to reduce to negative 3/8. Okay, and then I'm multiplying, so this is going to give me x to the 9th and y to the 4th. Now you could leave your answer like that, but I do want you to know that that x to the 9th and y to the 4th does belong with the numerator if you were to choose. So you can either kind of leave it off to the side, or you can put it very clearly with the negative 3 in the numerator. Either one is good. All right, guys, 3 more. Let's see here. So for 13, I think we should just start by dividing. Negative 7 divided by 56. If I reduce that, I get negative 1/8. And then x to the 3rd divided by x to the negative 3rd. So remember, I'm subtracting my exponents. 3 minus negative 3 gives me 6. So this will give me x to the 6th. It looks like y to the 6th divided by y to the 1st, which would be y to the 5th. And then z to the 9th divided by z to the negative 11th is 9 minus negative 11, which is 20. And that's it. No negative exponents to deal with. That's our final answer. Okay, number 14. So I think what we should do here is we should do our trick where we take the denominator and we move it into the numerator and we make that -2 into a +2. Only because if we continue on with making it like 1 over, we're going to have a complex fraction to deal with, okay? So let's try that. So I'm just going to rewrite this. -7a squared b to the 4th squared. But now I'm going to multiply it by this monomial because I'm bringing it to the top. Doesn't that just look nicer already? Okay, so let's go ahead and square each of these monomials. So 49, a to the 4th, b to the 8th, times 9, a to the -6, b to the 4th. Okay, now we're ready to multiply. 49 times 9 is 441. And then a to the 4th times a to the -6 is a to the -2. And b to the 8th times b to the 4th is b to the 12th. And then my last step is just to rewrite it. 441 b to the 12th stays in the numerator, and then a squared goes to the denominator. Now I have to tell you guys, there is a way that you could have done that problem that was, let me just count on my paper here. 1, 2, 3, 4, 5, 6, 7 steps. So I'm really happy that I thought of that before I showed you the other way. So it's good to know little tricks. It makes your life easier sometimes. Okay, last one. I would say let's use that trick again. I see that I have this monomial to the negative exponent in the denominator. Well, if I put it to the numerator, it becomes a positive. So I'm going to just rewrite this like that. So I put it to the top, that -1 becomes a +1, and then really that monomial to the first power doesn't change. And so again, nice, easy problem if you know that little trick. All right, guys, nice job.